Hello again, everybody. Today we're going to finish up chapter 5. So we're going to talk a little bit more about some loops, and then we're going to conclude with the basics of how to read and write files from your computer or flash drive or network drive or whatever it might be. So before we get to that, let me first talk about what a sentinel is. A sentinel is essentially something that marks like the end of some processing. So we can use sentinels to mark like the end of a stream of users input. A sentinel could be something that's used within a file to mark the end of reading data, whatever it might be. So essentially it's just some type of marker or some type of indication to tell your program to stop doing something. That's the idea. I think that the best way to illustrate this is via like a little program which will prompt the user and permit them to do something for a period of time until they enter some value, which will be their sentinel to essentially terminate that iteration of the loop or terminate the program. So let's go into Visual Studio here and let's try a little example. So I'm going to create a small example which will allow a user to enter a sequence of values until they indicate. I'm sorry, they're going to enter a sequence of values until they enter a sentinel, and then our loop will terminate and we will perform some processing. So it's going to be something like, a user gets to enter a bunch of scores and then we'll average them up, something like that. So what we're going to do is, since we're going to be using like the notion of scores, let's create a variable to hold the score, another variable to create, we're going to calculate the average of a bunch of scores, and then we're going to also need to have a variable for a total. So let's just get our variable declarations out of the way. So we're going to have a local variable for our score, another local variable for the running total. Actually, I'm going to initialize the total to 0, and also going to have a variable for our counter, and we're going to also initialize that guy to 0. And the way this is going to work, and this is probably a good example where we can use a do while loop. So let's it's not one that you see all that frequently. So let's use a do while loop. So we're going to say do while. So as long as somebody doesn't enter a value of -1, we're going to keep accumulating scores. So our value of -1 is going to be our sentinel, our marker to terminate summing up a bunch of values. Right? Okay. So I'm going to say do while, and we're going to say score is equal to something, right, other than -1. Remember, with the do while loop, you always need this guy at the end. You always need your semicolon, otherwise you'll get a compiler error. And here what we're going to do is we're just going to prompt the user. I don't know, we're just going to say cout, please enter a test score. So please enter a score or -1 to quit. All right, we could use -1 to quit, X, Q, whatever it might be, but we're just going to say -1 to quit. Put a little delimiter there. No endl. Right, we're going to accept the input on the line. And here's where we're actually going to capture the user's input. So we're going to capture these input and store that value in score. You'll notice here that on line 6, when I declared my variable score and total, I initialized total to 0, but I didn't initialize score. The reason is because I knew that I wasn't going to use a variable score until we were able to capture some user input. So it was safe for me not to have to initialize score to a value. However, total, I do need to initialize to a value because that's going to be my accumulator, and the same thing with count. And here's the idea. So as long as somebody didn't enter a value of -1, we're going to increment total, and we're going to increment the value for count. All right. So if score is not equal to -1, all right, what we're going to do is we're going to say total plus equals score. All right, so we're going to increment total by the value of score. So the first time around, it's going to go from 0 to whatever somebody enters for score. And we also need to keep track of the count Another reason is because at the end of our program, we're going to average these things. All right, we're going to average these values. So let me go down here and let's just display what the average is going to be at the end. So we'll say cout score count is equal to count, and we'll say average is equal to, here I'm not going to create a separate variable for average. I'm just going to calculate the average, which is going to be total, a double, right, divided by whatever count is, and that'll work. All right, I'm just going to do that in line. All right, that looks good. So what's going to happen? Let's imagine the first time around somebody gets this prompt. So notice this is a do while loop. We're guaranteed that it's going to execute at least once. So the first time around, user gets prompted to enter the score. We capture the score. If they entered the score of -1, okay, lines 12 through 14 would 12 through 15 actually wouldn't execute. Execution would jump down to line 16. We would find out that -1 is in fact equal to -1, so our do while loop would terminate, and we wouldn't have accumulate anything. Actually, to be honest with you, then over here I would have an error, because then I would try to do division by 0. We could clean it up if we wanted to. Second time around, say you run your program, somebody enters a value, let's say 10. We're here, we jump down to line 12. Was 10 not equal to -1? Yep, since it's not equal to -1, we're going to increment total, then we're going to increment count, jump down here to line 16, right? 10 is not equal to -1, so we're going to go back up and prompt the user again. And as long as they keep entering values other than -1, our program will continue to execute. So let's build this thing and run it, and you'll see how this works. So again, the idea behind this is it allows us to have a variable length input, so we're not hard coding, enter 10 values or what have you, like you might with a for loop. So let's use some simple numbers here. Let's do 10, 20, 30, right? So 10, 20, and 30, right? The sum of those things is equal to 60. So the average of those things right now would be 20. So I'm going to use -1 here. So -1 is going to terminate execution of my program, because right now my program is blocking on line 11. As soon as I hit the enter key, line 12 is going to evaluate the false. Line 16 will evaluate the true. My program will terminate, and we should get a proper answer here, right? So I entered 3 scores, and the average of those scores is equal to 20. So anyway, that's how you can use it as Sentinel. Again, and Sentinels are used for things other than just user input, and they're quite commonly used for when you're doing file input and output. All right, the next thing I want to talk about real quick is the concept of nested loops. So remember, a loop is something that's going to iterate some number of times. You can have within the body of a loop, okay, another loop, and if you do something like that, that's what's called a nested loop, and you can nest these things. I mean, theoretically, you can nest them as deep as you want, but it's not uncommon to see loops that are nested 2 levels deep, or maybe sometimes even 3 levels deep. Anything beyond that is usually fairly rare, but they can be, you can use them in that fashion. And there's a great example out of the book. I'm going to do this one with you guys, which illustrates how we can use a nested loop to sort of simulate how, like, how a digital clock would work, something along those lines. And the example's out of your book, so you can follow along there also. But I'm going to go ahead and run this through the compiler. So the idea is that you would have a far outer loop, which would simulate the hours, an inner loop from there, which would represent the minutes, and then a further inner loop, which would represent, the seconds. So it would be hours, minutes, seconds, working from the outside in. So let's take a look at, and we'll try this example together here real quick. Before I do that, I need to include another header file because I'm going to do some formatting. So remember back from doing formatting, you need to include this header file io manip. All right, this will allow you to do things like set the width of your stream, those types of things. So let me first initialize or configure my cout stream so that it's formatted properly. Then we can go ahead and start filling the thing up. All right, so let's do cout. Let's make this fixed width, and let's also make it so that it's right aligned. Let's also, and this is something new. I don't think I covered this last time, but it was in the previous chapter, I believe. What we can do is, if we want to fill our stream with something other than just plain white space, like the space character, we could fill it with any kind of character that we want. So in this example here, I'm going to fill my cout stream with, instead of the default space character, I'm going to fill it with the number 0. So this way, the number 9 will represent not just 9, but it'll be 09. So it's real simple. All you have to do is say cout.fill. There's a method that's called fill. And here we can specify which character is that we want to fill it with. So we could fill it with any character we want. I'm going to use the number 0 to do that. You'll see in a bit, if you follow along with this example, if you comment out line number 8 and run your program, you'll get a different output. So here's how this simple example is going to work. We're going to have 3 loops, all right? An outer for loop, an inner for loop, and then a further inner for loop. Each one of them is going to represent the hours, the minutes, and then the seconds. So my outer for loop is going to be for, I'm going to say int h is equal to 0, h representing hour. As long as h is less than 24, all right, increment the inner loop, or iterate, step into the inner loop, and then we need to do my update, which is going to be h++. Just to make this clear, I'm going to wrap these in, I don't think the book does it this way, but I think it'll help illustrate it for you guys a little bit better if I wrap these things in curly braces. So hours is going to be on the outside. On the inside, we're going to have minutes. So my minutes, int minutes is equal to 0 as long as minutes is less than 60, right? Then we say, let's use m. Let's not use min. Let's keep these to one character. We'll say m++. And now we're going to have our last inner loop, and this is going to be for int s is equal to 0, s standing for seconds. As long as s is less than 60, execute the loop, and then we'll do s++, and that's going to represent our seconds. So let me just make some little comments here just so that you can see. So this is seconds, this is the minute loop, this is the hour loop. All right. And the way that this is going to work is, first the hour loop is going to get tested on line number line. As long as we initialize hours h to 0, as long as h is less than 24, step into here. What does the body of the outer loop tell us to do? Well, let's jump into another loop. As long as minutes is equal, we initialize minutes as 0, as long as minutes is less than 60, step down into the inner loop. So we're going to keep nesting down further and further until we finally, as they say, hit bottom. And here we're going to initialize seconds as 0, as long as seconds, is less than 60. We're going to execute what's within this body of the loop. Once this body of the loop executes 60 times, execution is going to jump back out to here, and then we're going to increment m. We're going to check is m less than 60, so the second time around minutes will be 1. Since it's less than 60, we go back in here, and we're going to execute this 60 more times. Jump back up to here, increment this to 3, jump into here, execute this 6 more times. You get the idea. So eventually this is going to execute 60 times for every iteration of this loop. Once this loop is done executing its 60 times, execution is going to jump back out to here. We increment h to 1, as long as 1 is less than 24, right, which is true. We jump back into here, start all over again, jump back into here. and this process will continue. So this is going to execute. Total number of iterations is going to be equal to 60 times 24. So there's going to be quite a few iterations here, but on a computer it'll happen pretty quick. So within the inside body of my loop, all that I want to do is display the hours, the minutes, and the seconds. So I want to format this kind of nicely. So I'm going to say set W. We're going to make this 2. Probably wouldn't be a bad place to use a constant, but I'm going to keep it simple for now. Then we're going to display the value for H. Then we're going to do set width on the minutes. And we're going to set width for the seconds. Remember, here you just have to specify set width for each element that's going to be shoved into the input stream cout. Into the output stream cout. And then the last thing we're going to display is just the value for S, which is going to be seconds. The reason I want to keep these variables short to 1 character because otherwise I would have probably scrolled off the screen here. So that's it. So this is just going to display the hours, the minutes, and the seconds. So the very, very first time this is going to execute, hours is equal to 0, minutes is equal to 0, and seconds is equal to 0. This is going to execute 60 times, and then finally this is going to increment to 1. This is going to repeat 60 times again. This will increment to 2, so on and so forth. Eventually this will have to get bumped up, so hours is then going to equal to 1. This all starts over at 0 again. This will start at 0 again, and the process continues over and over and over again. So that's how you can use nested loops. I don't think you have any errors in here. Everything looks good. So let's see how this works. It's going to blow by on the screen fairly quickly, but you'll get the idea. And if you want, you could slow things down on your end. So if I just do Control F5 now, that didn't work. I got a problem. So I'm going to see what I did wrong. Hours, minutes, seconds. All right, I don't need to do. Let me use a little delimiter here for between hours and this guy. So this way you can see the delimiter between hours and the minutes. Let me do the same thing for the minutes. That will, let me scroll over a little bit so you can see everything. So I'm just feeding another string which is going to have a delimiter in here. Endel, I have Endel. Alright, let's see if this works now. Oh, something's wrong. Why is this appending off to the left? Let me see, something's wrong here. Set fill, fixed right. Let me figure this out, I'll be right back. Alright, I found what the error was that I had. I stared at it for a couple minutes and I figured it out. Here I had inadvertently put an M, right, for the set width. So it was setting the width of my output stream for minutes based upon whatever the value of M was. So as M was getting larger and larger, the width was getting larger and larger. So again, it wasn't a compile error, just a classical, logical error. So what I want to do is not make this, I don't want to make it the width of M, I just want to make it 2. Again, maybe another reason why it probably would be a good idea to use a constant here. So anyway, nonetheless, let me rebuild this thing and execute it, and you'll see what happens. Let me scroll off to the left a little bit here. So that's everything. So we do Control F5, and you'll see how this is incrementing, by the hour, by the minute, by the second. I'm not going to let the whole thing run by. You can try it on your own. It goes by fairly quickly. So anyway, so that's the idea. That's how you can use nested loops. Go ahead and play around with this. See what happens if you change the fill to something other than 0. If you want, I don't know, make it a make it a hyphen, make it a tab character. Don't fill it with anything, right? Just comment out line 8 if you want, and see what the different behaviors are. There it is all over. So anyway, it ends at what, 23, 59, 59. So that's how we can use nested for loops. All right, the last thing we're going to cover in this chapter is how to read and write data from files or storage. Remember way back when we started this course, anytime that we did any type of manipulation with data, it was always something that we hard-coded into our program. Then we saw, okay, how can we get data into our program without hard-coding it? And we learned how to capture user input from the keyboard, right? And then obviously we always were able to display output to our console. However, probably one of the most common ways of getting data into and out of your program is via files. Okay, and those files could be something that exists on your computer. They could exist on a flash drive. They could exist over a network drive. They could exist over a HTTP URL type of a stream, right? Reading in like a file off of a web server somewhere. So it's super common to be able to read and write data from files. One step further is taking your program and attaching it to a database, which is essentially a file repository, and that's another way that we can use files. So what we're going to do in this chapter is we're just going to do some basics just so you can learn how to read values in from a file, and also show you how you can read values out to a file. Later on, if you take a second half of this course, you spend a little bit more time how to do some of the more advanced input and output operations on files, like how to read and write both text and binary files. In this course, we're just going to focus on how to read and write text files. So anyway, I would definitely read through this section 5.11 just so you can understand high level, kind of like what's going on behind the scenes. And there's actually quite a bit of stuff that is kind of wrapped up for you for free. And if you just know how to use the proper API or the proper method or function calls, you'll be able to read and write from files. But a lot of the complexity is hidden for you. That's the idea. So let's and actually I think there's a couple of good diagrams in here. One shows you here how things are like stored on a disk. Whether it's a disk or a flash drive, it doesn't really matter. It's the same idea. And then also talks a little about some of the different types of methods. The different types of files. What's the difference between a text file and a binary file? You can take a read through that if you want. It's definitely worth knowing. So what we're going to do is we're just going to do some basic stuff. So we're going to learn how to read and write from a file. First thing we're going to do is I'm going to show you how to write to a file. So let's, before we can use any of the file methods or functions, we need to include another header file. So I'm going to say #include. And it's going to be the fstream header file. All right, so fstream stands for file stream, and that's going to include all the things that are necessary, for us to write out to a file. So let's do this. Let me before I open up a file, let me just so we have something that can display on the screen. We're just going to display file, just to just so that you can see that we're doing file output. All right, file output. Next thing that we need to do is we need to actually create an object which is going to be the connection to our output file stream. This is kind of similar to what we did before when we used the string data type. Remember, the string data type is not one of the primitive data types. It's actually what's called a class or an object type. In this case here, when we want to write out to a file, we need to use a class or object type of type OFStream, which stands for output file stream, which is again very similar to what a string is, in the sense that it's not a primitive type. So the type is going to be OFStream, okay, which is my output file stream, and then I'm just going to give it a name. So it's going to be out. So out is going to be my connection to my output file. What is the file? What is this type? The type is OFStream. So remember, it's really no different than saying like int x, right? Int is the type, right? Int x, right? Int is the type, x is the variable name. Here, OFStream is the type, out is the variable name. Right? So again, these are non-primitive types. So the first thing that we need to do in order for us to be able to write out to a file is that you need to establish that connection to the output file stream, and that is done via the open member function of the output file stream. So here we just simply say out.open, and we need to give it a file name. I'm just going to hard code this, right? We know what is a file name we're going to do. I don't know, I'm just going to call it out.text. Okay, that's good enough. So it's going to be a text file that's called out. This actually takes two parameters. The second one technically isn't necessary. I like to do this only because it explicitly tells you how you're opening up the output file. this is documented. It's probably in a book. If not, you could look online. But there's a bunch of different what are called flags or modes. So the idea is that you can open up an output file in the default behavior, which is just considered to be out. And here I'll say iOS out. Right? And this is the default behavior, meaning that when you write out to this file called out.txt, if there's anything in that file, you're going to overwrite it. You can also open output files so that when you open up the file, you might want to append to the file. So instead of truncating the file, what you'll do is you'll just append whatever values that you'll append to the end of the file, which is a common task to do also. So the default that we're going to use here is we're just going to say that it's a to overwrite any values that may be in there. So once we open up the file, remember by open it's just our logical connection, or what they refer to typically as our handle, right? That's going to be our handle to the file. But before we go ahead and try to write anything to the file, it's always a good idea to make sure that the file open was successful. The reason is because there could be a whole bunch of reasons why the open method could fail. Number one, maybe something this is probably more obscure. Maybe your disk is full and you can't write to it. Another one might be maybe you're trying to write to a location on your hard drive, or your operating system restricts you to write to. There could be permissions that won't allow you to write to the default location where you are right now. You could be trying to write to a network location that is not valid for you. A whole bunch of things where you might be trying to open up a file that doesn't have the proper format for the operating system. So you might have some characters in the output file, like, I don't know, the dollar sign or the percent sign, things that are not valid by the operating system. Anyway, so the idea is that there's a whole bunch of reasons why opening up a file could fail. So before you go ahead and try to write to the file, it's always a good idea to test to see that if it's open, okay, or if it's valid. So here what we'll do is we're just going to take we're going to do a little test, and we're going to say as long as my output did not fail, okay, then what we're going to do is we're going to write something out to my file. So here I'm just going to say cout hello. Now let's do this hello world. All right, let's do this guy, hello world. Since we're working with text files, you'll notice that I can just use the stream insertion operator to take something. Oh, I did cout, my mistake. It's not cout. Cout is a console. What I want to do is I want to write to my output file stream, which is just referred to as out. So I'm going to take what's on the right side of my stream insertion operator, which is just hello world, and shove that into my output file stream. Now, what's nice about the basics of file input and output in C++ is that you can, for almost all the cases, you can use the stream insertion and extraction operators to read and write data from a file. So that will write the value out to the file. So if this did fail, then what I'd want to do is capture that error, meaning that there was some problem. And here I'm just going to display something to the console, and I'm just going to say cout error opening file, something like that. That's good enough. Okay. Error opening file, that would just be an indication to the console that there was a problem. All right. It's always a good idea that once you open up a file stream, that you explicitly close it at the end. In this type of program where it's short and have a little main program, it's really not necessary. However, when we look into functions later on, you'll see that then it becomes somewhat necessary to explicitly close your output file stream. So here I just need to say out.close. All right. What that will do is it will take everything that's in the output file stream, what's called buffer. It'll write it out to that location on disk, whether it's your hard drive or flash drive or network drive or whatever it might be, and it'll close that connection, which then can be reused again. And here I'm going to do at the end of my program, I'll just do a little cout, and I'm going to say done, just so you can see something displayed at the console. All right. So let me just step through this real quick now that we have the basics here. So what's going to happen is on line 9, we're going to create our output file stream object. On line 10, we're going to open up the connection to that output file stream. As long as that output file stream is connected or open successfully, we're going to take the string hello world and shove that into my output file stream along with the endl operator. If this did fail, then what's going to happen is instead we're going to, instead of trying to write to the file, what we're going to do is we're going to just display an error, display a message error opening file. Once all that's done, we're going to close my output file stream just to clean up. You could try this later if you want. Comment this out. You'll see that it'll still work. And here what we're going to do is we're just going to display the value done to my to the console. So let's run this real quick and let me show you how this works. So the only thing that you should see displaying on a console, everything goes well. It should just say file output and then done. Then I'll go in and I'll show you where that text file is. So if I run this thing, file output and done, so it looks like everything works successfully. Now what I want to do is I want to find out, okay, well, if I wrote out to this file, where is this thing, right? Where is this file that's called out.txt? The reason is because I didn't give it a fully qualified path. Like, for example, I'm working on a PC right here, so I didn't say, C:\\temp / comps142 / out.txt or something. So what's going to happen is the Visual Studio will use the default project location for the location of this file that's called out.txt. So you could use either Windows Explorer to navigate and find this thing, or what I find to be the easiest way to do this, if you just click on open file. This should bring you to the root directory of your project, not your solution, but the root directory of your project. So I have a solution that's called lesson examples, and a project that's called lesson examples. And within here, you'll see that there's an output file that's called out.txt. This is the thing that just got written, right? 9:24 a.m. That's the date that I have on here. I'm going to click open, and you'll see that it has the string hello world in there. And you also see that there's a second line. Why is there a second line? Because I put the endl operator in my output file stream. So that's it. So that's hello world. So that's like the real basics of how you can write out to a file. Let me close this out, and let's close that also. Let's go into here, and you know what? We're going to write hello world, and we're just going to write this little loop here, which is going to write some other data to a file, so you can see that you can write not just strings, but you can also write numerical values to a file if you want. So here I'm just going to create a little for loop for int I is equal to, let's say 1, right? As long as I is less than or equal to 10, say I plus plus, and here we're going to say out, not cout, but out, and take whatever the value of I is, and then with a new line operator. And what this will do is on line 14 and 15, this is a loop which is going to count from 1 to 10 inclusively. Every time this loop iterates, it's going to take the value of I and shove it into my output file stream, which is connected to my out.txt, and then the endl operator. So at the end of the day, what should happen is I should have my file out.txt should say hello world, and then the 10 values below it, 1 through 10. So let's build this thing and run it. Let's see what we get. Control F5. File output. Do I have an error in here somewhere? Why is it not done? Let me see if there's a problem here. Let me open up my output file. This should just do, so this is the end of my for loop. Out I is equal to 1, I plus plus. Let's see what out.txt looks like. Maybe I have an error here. Stupid mistake. Right. Not 1 is less than or equal to 10, right? 1 is always going to be less than or equal to 10. It's I, right? I is less than or equal to 10. So if I look at my out.txt file right now, since I had an infinite loop running here, I terminated my program quickly, you could see that I actually wrote out a whole bunch of values to my program, right? It got up to, the 673,000 range. That's not what I wanted. So let me rerun this again. F7. This looks better. So file output done. You can see that went much quicker. Let's go look at out.txt. Open file, out.txt. And you'll see it says hello world and the values 1 through 10. You'll notice too, and I want to emphasize this, is that this truncated the file that was there before. Remember my previous error that I had like 672,000 values in that file. Right now this only counts for, this says hello world and 1 through 10. That's the reason why it says just that, is because since I opened up my file in the default mode, which is to append, I'm sorry, not to append, to truncate, it'll take whatever values in our file, it'll wipe it clean and start from the beginning again. So truncation works a little bit different than appending. It actually works a lot different. So that's how we can write out to a file. I would definitely try this example here. Make sure you're comfortable with how to do output, and then you can move on, and then let's try to do some input. So just as before, while it's common to write data out to a file, it's also common to read values from a file. And the way that we do input into our program is via instead of the OFStream class, as we have represented on the line 9, we're going to use the IF meaning input file stream class. So let's do this. I'm going to reuse a bunch of my code here just to be lazy, all right? And I'm going to change this from file output, and we're going to now do file input. By the way, your program can do input and output at the same time. I'm just trying to just do this in a somewhat modular fashion just to keep it a little bit simple. So let's do file input here, and now what I'm going to do is I'm going to create not an output file stream but an input file stream, which is called IFStream, and I'm going to call this guy in. And that's going to be a connection to my input file stream. Now I have to clean up some of my errors here. So I need to change out to in. And we're going to open, let's do this. I have a file that's on my computer. It's called students. You'll see it in a second. It's called students.txt. And we're going to open this not in output mode, but I'm going to open it in the default, which is called input mode, which will read from the beginning of the file. And now here we're going to do a little test again, and we need to check that the input file didn't fail. Okay, if it didn't fail, then we're going to go ahead and do something. I'm just going to get rid of that for a second. All right, error opening file, that's fine. And now we're going to say in.close. And then done. So just as before, it's a good habit to close your output files. It's also a good idea to close your input files. Basically, what you're doing is you're telling the operating system that you're releasing your handle to this file. And if another program or application wants to open up that file, for example, you want to use Notepad or whatever other program you might need to use to open up that file, you're telling the operating system, I'm done. Somebody else is now free to go ahead and pick up where I left off. So let me show you what this file that's called student.txt looks like. All right, so if I go to File, Open File, students.txt, when you're trying to do your input, you can just create a little file that's called, whatever you want to call it, and just put some data in just so that you can see that it works. So there's probably files on your computer that already have some kind of text values in there that you could use, but I create a little simple one here just so that you guys can see how this works. So here's a list of a bunch of names, all right? And the idea is that this is sitting on my local drive in the root directory of my projects folder. And what I want to do is I want to go ahead and read in all of these values that are in that file. So the way that we do that is, so all this is set. This is pretty much like pre-canned. The way this is going to, you could use this for your future labs or what have you. And what we're going to do is now we're going to use the input file and extract out each one of those values from my input file, and what we'll do is we're just going to echo it or display it to my console. So since those values that are stored in that text file are essentially strings because they're student names, let me create a local variable of type string. name, right? And these are going to be the things that this is where I'm going to read the values in and store it in memory within my program. And what's nice about input file streams and output file streams within C++ is that it's a good place to use while loops because there's a simple way to detect the end of a file by using the stream, well, at least for an input file stream. Easy way to determine when you've hit the bottom of the file or the end of the file is just by using the stream extraction operator. So while loops are a really good candidate for using in your program to read through a file because you don't necessarily always know what the length of the file is. There could be 3 names in a file. There could be 40 million names in a file. You don't know. And you don't need to know because behind the scenes, the API or the program, the C++ libraries will take care of that for you. So I'm going to say while. So I'm going to take my input file stream and read it into name. Right? So on this line 14, this little expression here, okay, we're going to extract the next line within my input file stream and store it in the variable name. This will always return true until we reach the end of the file. So as long as that continues to return true, what we can do is we can just then go ahead out and we'll just echo out, see out, just so you can see that it's reading in from the file. I'm just going to say echo, name. All right. So this will display each one of remind me later. This will display each one of the values within my program. So eventually this expression here will return false. Because I will reach the what's referred to as the end of the file. Take a look through that section in your book and just so you can understand how the end of file concept works. So this makes life a lot easier for us because we don't need to worry about upfront knowing what the length of the file is because the operating system will indicate to our program and via the C++ libraries when we've reached the end of our file. So let's build this thing and run it. And you'll see that we should have this displayed to our console, and we do, right? So we're doing file input. We echo out all the names, and I believe the last name was Jill. Let's just make sure that was truly the end of the file. Right, so there's, right. So this is student.txt, Sue, Mary, Joe, Chris, Sam, Matt, Bob, Brian, and Jill. So that read everything in. If the length of this file changes, the length of my output will change. Let me also mention that this is the stream extraction operator, and the stream extraction operator here is reading a value and storing it in a string. You don't need to store these things as a string. If you have values in your input files that might be numeric, they could be integers or doubles or floats or what have you. You can also read in those input values and store them in a corresponding variable. So imagine, here, let me go into my, let me open up my hello world. Remember it was called out.txt? Let me rename this. I'll call this numbers.txt. So I'm going to call this numbers.txt. Let me make these values all numeric. All right, so here I have a text file which has 10 numeric values in there. Let me just close this thing out and save it. All right, so those are all integers. Now let me do is I'm going to open up numbers.txt. Open up numbers.txt, and now what we're going to do is instead of reading these things as strings, I'm going to read them in as int num, right, numbers. I could then go ahead and add up those numbers, sum up the numbers, or I could calculate the average, whatever. You get the idea. You could do anything you want with the numbers there. Num, right? The idea here is I want you to see that we are not forced to read things as strings. We could read them as integers or floats or doubles or booleans or characters, whatever they may be. I already built this. So let's run this. So now it'll echo out those numerical values, and then when they are read in from the file, they are actually read in as integers. So you can do mathematical things with these things. You don't need to treat them as strings. So anyway, that wraps up file input and output. Make sure you understand this, and definitely, well, first of all, you're gonna have a lab or two to do it for this lesson, but more importantly, make sure you understand this, and you maybe try some of the examples in the book, and do some things which will cause this to fail. I mean, that's kind of how you learn. The reason is because when you have to do the final lab in this class, you're gonna have to be doing some reading and writing to a file. So it's a good idea to just make sure that you understand all these concepts. So anyway, that's it for chapter 5. Have a good week.